Hey guys, so today we're going to do the solutions to the short answer in the revision test. This will probably be split across a couple of videos because it'll probably go a bit too long for one video. So again, make sure you've done the actual test yourself first before having a look at the answers. Alright, so with this one we got three different matrices, A, B and C, and we're required to do a number of operations with them. A and B are pretty straightforward, D is also not too bad. C probably being the hardest one because it requires matrix multiplication. So C plus B, alright, so C is a 2 by 1, as is B. Remember, the order of a matrix must be the same for it to be added and subtracted. Sometimes you will get a trick question where you're asked to add and subtract and it's trying to set you up for failure. If that's the case, you just say not possible. Alright, pretty easy. Just add the numbers in the corresponding spots. 3 plus 1 is 4, 2 plus 0 is 2. So that's our answer. B is B take 2C. Alright, again, B is 1, 0 minus 2 times C. Alright, so in this case you do the multiplication first, the scalar multiplication. It's like normal BIDMAS, you need to do the multiplication first before you subtract. So if I was to rewrite that, I'll do it down here. So 2 times 3 is 6, 2 times 2 is 4. Now it's just normal subtraction. 1 minus 6 is negative 5. 0 minus 4 is negative 4. C. AB plus C. Alright, so this one's got the matrix multiplication in it. I'm going to do the A times B part first. Alright, so A is a 2 by 2, C is a 2 by 1, so this is going to equal a 2 by 1 matrix. As far as matrix multiplications go, this one is pretty straightforward. So 2 times 1 is 2, plus 3 times 0 is still just 2. 1 times 1 is 1, 4 times 0 is 0, so 1 times 1 is just 1. So that's just going to equal that. So it's AB, this answer, plus C. C being 3, 2. So I'm just going to have to write this small. Alright, 2 plus 3 is 5. 1 plus 2 is 3. So that's an answer, a 2 by 1 matrix with elements 5 and 3. Sorry if I feel like I'm rushing, there is just a bit to get through with this one. Alright, 1.5 times A, so again, scalar multiplication where you multiply a matrix by a number. So remember, you just multiply it to every single element within the matrix. As per normal, it doesn't matter whether you write your final answer as a fraction or a decimal. I don't care about that. Both are acceptable. Alright, 1.5 times 2 is 3. 1.5 times 3 is 4.5. 4.5 and 6. Those are your answers to question 1. Where did I put my clicker? Hang on. Alright, sorry about that. Matrix D has an order of 3 by 2. E has an order of 1 by P. F has an order of 2 by 2. For what value of P would the product matrix ED exist? All right, so if E times D, E being 1 by P times by D, which has an order of 3 by 2. Right, so it says for what value of P would the product matrix ED exist? Remember, these two middle numbers have to be the same. So for this to exist, P simply has to be 3. Best way to do those ones is just to write it out like that, and then you can visually see what you need your value to be. If the product matrix H exists and H equals EDF, state the order of H. All right, so again, I'm going to write them out next to each other. This one's a bit different to anything we've done because there are 3 matrices. So we need to write all 3 orders next to each other. So it's E times D times F. All right, now when this is the case, it's still the 2 outside numbers, it's just the 2 very outside numbers on all 3 brackets. So the resulting matrix from this would be a 1 by 2. So matrix H, the resulting matrix, would be a 1 by 2. Alright, the table below shows the 3 different ticket prices in dollars and the number of tickets sold for a school concert. A says construct a column matrix to represent the ticket prices for adults, children, students, and teachers respectively. Okay, so what we need to do is take those 3 ticket price values and just put them into a column matrix. Nice and easy. So there's 3 values. First ticket price is $12.50. Next one is $6. Next one is $10. 3B, perform a matrix multiplication to determine the total amount of ticket sales in dollars. Okay, this is basically saying, all right, how much money is made in total? This is where you're taking the ticket prices for each one and multiplying it by the number of tickets sold and then adding it all up. If this was done in matrix form, it would look like this, where you have a row matrix with the number of tickets sold. Sorry, my market's a bit small. So those are the number of tickets sold. And you multiply it to the matrix we came over here, the column one. Okay. This is a 1 by 3, this is a 3 by 1, so they're defined. 1 by 3, 3 by 1, the resulting matrix will be a 1 by 1. Which is the amount of money that they're going to make in total. I'm not going to write out the full workings, but if you do that, so 140 times that, that times that, that times that, you get a grand total of $4,000. And so that is the answer to 3B. Question 4. State whether each of the following multiplications are possible and why. All right, so we have 2 here. In 4A, I'm just going to write out their orders, not the actual matrices themselves. The first one is a 1 by 2 matrix. The second is a 2 by 1. The 2 middle numbers are the same. Now this one says state why, so you do have to have a little bit of justification. I would just say something like, yes, the, what would I say? Number of columns in the first matrix is equal to the row in second. That answer is perfectly acceptable for both 4A and 4B because they have the same answer, so I'm not going to bother writing it out twice. But when you need to justify something like that, that's a perfectly fine response. You don't need a paragraph, it is only a 1 mark question, so 1 sentence is fine. Alright, I'm going to pause the video there and do a second one for the remaining questions.